Hi Math 9s, welcome to this week's video all about chords. So we're still working with our circle geometry unit. Last week we talked about tangents. Today we're moving on to another part of our circle geometry. Please keep Pythagorean theorem in mind. It will be very, very helpful again this week. But before we jump in, I want to just review some triangle properties that we should be aware of from previous grades. So remember, a triangle is a three-sided shape, and we can classify them in a few different ways. I want to talk about how we can classify them by the lengths of their sides. So remember, an equilateral triangle means that all three sides are equal. They're all the same. And remember, we can represent that by using a dash to show that they are all the same length. And remember, if all of our sides are the same length, all angles will also be the same. So they'll all be 60 degrees, or they'll each be 60 degrees. If we have a triangle where only two sides are equal, this is an isosceles triangle. So remember, with isosceles triangle, if those two sides there are the same, the angles from those sides will also be equal. So we can use our angle symbols to represent our equal angles. This angle up here at the top will be different, but these two angles down here will be the same. And this will help us with some of our questions. And then remember, a scalene triangle, we won't deal with these very often, but scalene means that the three sides are different lengths, and the three interior angles will all be different. One other thing I want to make sure we understand, the interior angles of a triangle add to 180 degrees. So we reviewed this last week, but just one more time to make sure that we understand. Remember, give me 1 second here. Remember, this symbol here represents a right angle, which means 90 degrees. So for this triangle here, I would go 180 minus the 90 minus the 45 to find missing angle P. And if I plug that into my calculator or use my mental math, I know that angle P would be 45 degrees. We can do the same thing here for angle F. Let me change color. So basically, if I go 180 minus my 30 degrees minus my 40 degrees, I end up with 110 degrees for angle F. Number 3 here, I'm looking for angle G up at the top. I see 80 and 80, which is interesting. It means that this is a isosceles triangle and isosceles triangle. So I would go 180 minus 80 minus 80, which leaves me with 20 degrees for angle G. So please remember, interior angles of a triangle add to 180 degrees. So jumping into this week's topic for circle geometry, we're going to be talking about chords. So remember, last week, a tangent is a line that intersects our circle at one point. So this line here would be a chord. Sorry, a tangent. This week, though, we're talking about something a little bit different. So a chord is a line segment that joins 2 points on a circle. So that's a really simple definition. So if I have a point here and a point here, and I draw a line connecting those, I end up with a chord. There's a chord. If I have 2 points like this, and I have a line segment that connects them, and it passes through the center, we'll say the center's there, approximately. This is a diameter. So a diameter is a special example of a chord, and the diameter would be actually the longest chord that we could get in this circle, because any other chord is going to be shorter than that. So that's kind of neat. So basically, both of these are examples of chords, a line segment that joins 2 points on a circle. So something that we really, really want to keep in mind, and I'm going to read this with our math language first. a perpendicular line from the center of our circle bisects the chord. So there's a couple things going on here. So basically what this means is if I have the center of the circle, let's say it's there, I'll label it O, and I draw a line from the center of that circle, and this is not perfect by any means, but we can use our imagination. I draw a line from the center of that circle to my chord, it will make a 90-degree angle. And remember, that means our little square symbol there, a right angle. So that's what it means by a perpendicular line. Remember, perpendicular means 90 degrees. Something else that's really cool is that when I draw this perpendicular line and it meets my chord, it ends up splitting my chord into two equal line segments. So what that means when I say bisects, I just mean that it cuts the chord into two equal parts. So if I label this point here B, I've said over here that chord AC is 6 centimeters, so this length here is 6 centimeters. What that means is that AB, line AB, equals half of that, so 3 centimeters. And line segment BC is also 3 centimeters. It cuts them perfectly in half. So keeping these properties in mind, we'll be able to solve some problems, usually involving Pythagorean theorem, keeping in mind that we have a 90-degree angle here, they're perpendicular, and it cuts my chord into two equal parts. So let's look at our first example. Point O is the center of a circle, okay, and line segment OC here bisects chord AB. And they've shown us that with these little tick marks. They've shown us AC here is the same length as BC here. Okay, perfect. They tell us that angle OAC equals 33 degrees. OAC. So that means this angle here is 33. Okay, they've labeled it for us. Perfect. Determine the values of X degree and Y degree. So I'm trying to find this angle here and this angle over here. Well, there's a couple of different places that we can start, but let's start with Y. So remember, if we have our bisector, it means that that right there is a 90-degree angle. So angle Y is going to be equal to 180 degrees minus 90 minus 30. So angle Y is 60 degrees. Whoa, sorry, that's my mistake. Not 30, 33. Which gives us 57 degrees. My mistake. So Y is 57. X, let's think here. So X, we're looking for, let me change my color. X, we're looking for this angle here. Well, the easiest way that I can think about is that OA is a radius. OB is also a radius. So if I know that two sides are the same, I have an isosceles triangle. If I think back to what we were talking about at the beginning of this presentation, when I have an isosceles triangle, these angles at the bottom here from our two equal sides are going to be equal. So using what we know about our isosceles triangles, we know that X will also be 33 degrees. Example number 2, point O is the center of a circle. AB is a diameter. Okay, so they gave us a diameter here, and they've labeled it 26 centimeters. Okay, perfect. CD is a chord that is 10 centimeters from the center of the circle. So there's my chord, and it is 10 centimeters from the center of the circle. What is the length of chord CD? So I'm trying to find this distance all the way from C to D. Okay, couple things we could do. I'm just going to walk you guys through the way that I would think about this, but of course there's different ways you can think about it. Remember, when we have our perpendicular 90-degree angle from the center to our chord, it splits these into 2 equal parts. So if I know that this side here and this side here are equal, if I can find 1/2, I can multiply it by 2 to find the whole chord. And remember, I mentioned that Pythagorean theorem is what we'll really be using to help us with this. So if I draw a radius from the center of the circle to point C, I make a right triangle. Aha! So remember, 90-degree angle. I have my hypotenuse over here on this side. If I can find this side, that would be awesome. Okay, but I'm missing this length here. This length, though, is a radius. It goes from the center of the circle to the edge. They gave us our diameter. Aha! Remember, radius is 1/2 of the diameter. So that means that radius is going to be 26 divided by 2, 13 centimeters. So I can go in, I know this side is 13 centimeters. So I just had to create my own triangle using the information that I knew. So can I find this missing blue side from C to E? Absolutely, Pythagorean theorem. So remember, a squared plus b squared equals c squared. I have my hypotenuse, so I need to do, I'm going to say, let me just sketch out my triangle over here. So I know this is 13. I know this is 10. There's my right angle. I'm trying to find this. I'm just going to label A, B, C. So if I'm trying to find A, remember A squared equals C squared minus B squared. So A equals the square root of C squared minus B squared. You might plug in your answers and solve it, or plug in your values and solve it, however you want to do it. So A equals the square root of 13 squared minus 10 squared. So please be careful when you're plugging in your numbers. So the square root of 13 squared minus 10 squared gives me a length of 8.3 centimeters. I'm not done though. Let's think about what we just found. We just found the length from C to E. What am I trying to find? I'm trying to find from C to D. So I need to take 8.3 and multiply it by 2. So I would say chord CD is 16.6 centimeters. Our last example for today, this is an example that's really, really similar to the types of questions they would ask on a PAT exam. So it's going to require some thinking. A horizontal pipe has a circular cross-section. So there's the cross-section with center, its radius is 20 centimeters. And they labeled that here from O to A. Water fills less than 1/2 of the pipe. Okay, they've kind of shaded it in for us. We got it. The surface of the water, AB, so from A to B, is 24 centimeters wide. They didn't label that for us, but we know, okay. Determine the maximum depth of water, CD. So we're trying to find from C to D. Please don't try to draw in triangles like this. When have we ever done something like this? Never. So don't try to make up math. Try to think about what we know. Well, if I know the length from O to C, that would probably be helpful because I know that O to D is the same as my radius. So if I can find O to C, that will help me figure out what C to D is. If that doesn't make sense, I'll walk you through it. So let's use the triangle that they've given us. So we know that this side here is 20 centimeters. Okay. I know here's my 90-degree angle. I know the surface of the water from A to B is 24 centimeters wide. So A to B is 24, but I know that these two halves are the same. So I know that A to C is half of 24, or 12. I know two sides, I can find the other side. So I'm just going to sketch that out over here. So I know 20, I know 12. I'm trying to find this side. I'm going to label C, B, and A. So just like last time, A equals the square root of C squared minus B squared. So A is going to be the square root of 20 squared minus 12 squared. So bear with me while I punch this in. 20 squared minus 12 squared, and I take the square root of that. I end up with A equaling 16 centimeters. Is that my answer? No, that's just the length from O to C. So O to C is 16. I am trying to find C to D. So again, I'm going to just sketch this out over here. So here's my circle. I know it's not perfect. There's the center. I know that this length is 16. That's what I just found. I also know that this length in blue is the radius, which is 20. If I can find the difference between those, I can find this depth here. So basically, if the center to the surface of the water is 16 and the center to the bottom of the water is 20, how deep is the water? Well, one last step, 20 centimeters minus 16 centimeters gives me a depth of 4 centimeters. So my final answer would be 4 centimeters. One thing to keep in mind, it actually is important that they told us that water fills less than 1/2 of the pipe. If they didn't specify that, we actually could have had the water all the way up to here. And we could have been figuring out that depth there, which we could do. I don't think we would have a problem doing that. But just be careful with what the questions are asking. And that's it for chords. If you have any questions, please shoot me an email. Let me know. Make sure you do some practice. Thanks, grade 9s.